Hey everyone, and welcome to The Explainer. Have you ever wondered how your computer can search through millions of files or songs or contacts and find the exact one you want in basically no time at all? Well, the magic behind that incredible speed is often a clever programming tool called a hash map. Today, we're going to pull back the curtain on hash maps and their cousin, hash sets, and really show you how they work.
I want you to imagine something. You've got a gigantic, messy pile with a million different items in it. How in the world could you possibly find the one specific thing you're looking for almost instantly? Without having to check every single one. It sounds kind of impossible, right? Well, it turns out it's not impossible at all. Programmers have this secret weapon to solve this exact problem, and it's called hashing. It's the engine running behind so much of the high-speed tech we use every day. So let's break down exactly how it gives us these superpowers. So here's how we're going to do it. First, we'll talk about why we even need this kind of speed. Then, we'll explain what hash maps and sets actually are. After that, we'll see them in action, solving a couple of classic coding problems. And finally, we'll talk about how you can use this new superpower in your own work. Okay, so Section 1, the need for speed. Look, in computing, we're dealing with just enormous amounts of data. And searching through it one piece at a time, what we call a brute force search, is like trying to find one specific grain of sand on a beach by looking at them one by one. It's just painfully slow, it's inefficient, and for any real-world application, it just doesn't work. There has to be a better way. And the difference is, well, it's staggering. Just look at this chart. That bar on the left, that's your brute force search. The more data you have, the taller it gets, the longer it takes. But look at the bar for hashing on the right. That flat line, that's the whole secret. It means the search time is always the same. We call it constant time. It literally doesn't matter if you have 10 items or 10 million. The lookup is practically instant. That is a total game changer. So how do we get that incredible speed? Let's meet our new tools. We're going to talk about the hash map, which I want you to think of as a box of perfectly labeled drawers. And we'll talk about the hash set, which is basically a super efficient checklist.
Okay, so first up, the hash map. At its core, it's just a way to store information in pairs. You have a key and you have a value. The key is the unique thing you use to look stuff up, and the value is the data you actually want to get. It's just like a phone book, right? The key is the person's name, and the value is their phone number. And the best way to picture this is that box of little labeled drawers. If you want to find out how much an apple costs, you don't start rummaging through every single drawer in the box, right? No way. You just go straight to the drawer with the label apple on it and open it. It's that direct access that makes it so unbelievably fast. So let's get this clear. What's the difference between a map and a set? Well, the hash map on the left stores a key and its related value, like an apple and its price tag. It's perfect when you need to look something up or count how many of something you have. But a hash set, over on the right, is even simpler. It only stores the key. Its only job is to instantly tell you, yep, I've seen that before, or nope, first time. It's built purely for checking if something exists or finding duplicates. So yeah, the perfect analogy for a hash set is a simple checklist. Imagine you're collecting trading cards. Before you make a trade, you just glance at your checklist to see if you already have that card. You don't care about its stats or its picture, you just need a quick yes or no. That's the simple, beautiful power of a hash set. All right, theory is great, but let's see these things actually work. We're going to walk through two classic coding problems to show you just how powerful and effective hashing can be in the real world. Okay, problem number 1. This is a classic, you'll see it everywhere. It's often called twosome. The setup is simple. You get a list of numbers and a target number. Your job is to find two numbers in that list that add up exactly to that target. So, for instance, let's say our list of numbers is -1, 3, 4, 2, and our target is 3. The answer, pretty clearly, is -1 and 4 because they add up to 3. The goal here is to return their locations in the list. Now, without a hash map, you might have to check every single possible pair of numbers. And if this list had a million numbers in it, well, good luck with that. So how do we do this the fast way? We use a hash map to keep track of the numbers we've already seen. As we go through the list, we look at each number. Let's start with -1. We do a quick calculation. What number do I need to hit my target of 3? Well, 3 minus -1 is 4. So now we just ask our map, hey, map, have you seen a 4 yet? The map instantly says, nope. So we say, okay, no problem. And we add the number we're on, -1, to our map. Then we just move on. Eventually, we get to the number 4. We ask again, what partner do I need? Ah, I need a -1. Hey, map, have you seen a -1? And this time, the map instantly says, yes, I have. I saw it earlier. And boom, right there, we have our answer.
And that right there is the magic. That question, have you seen this number before? It gets answered instantly by the hash map. We never have to go back and scan the list again. This nearly instant lookup is what we call O1, or constant time. It's what makes the entire solution just fly.
Okay, so a hash map is amazing for finding pairs, but what about just checking for duplicates? And what if you have to check for them in multiple places all at once? A perfect problem for this is verifying a Sudoku board. You know the rules. No duplicate numbers in any single row, any single column, or any of the 9 3x3 boxes. So what's the trick? You guessed it, hash sets. We'll use them as our checklists. But here's the clever part. For every single number we look at on the board, we actually have to check 3 things at the same time. Is this number unique in its row? Is it unique in its column? And is it unique in its little 3x3 box? So here's how it works. We create a whole bunch of hash sets, one for every row, one for every column, and one for every 3x3 box. Then, as we go through the board one cell at a time, we look at the number and we just ask our 3 checklists. Is this number already in its row set? Is it in its column set? Is it in its box set? If the answer to any of those is yes, we stop. The board's invalid. Game over. But if the answer is no, we just add the number to all 3 of those checklists and move on to the next cell. It's an incredibly clean and incredibly fast way to solve this.
So you've seen the power, you've seen the speed. Now let's talk about how to make this your superpower. It all comes down to knowing exactly when to pull these tools out of your toolkit.
So when should you be thinking about hashing? Just listen for these keywords. If a problem asks you to count the frequency of items, think hash map. If you're checking for uniqueness or finding duplicates, HashSet is your best friend. If you need to build a dictionary or some kind of mapping, that's a hash map. But honestly, the biggest signal is this. Anytime a problem screams, I need fast lookups, hashing should be the first thing that pops into your head. And this isn't just for abstract problems. Your web browser's cache uses this every single day to instantly check if it's already downloaded an image, which is why websites can load so fast.
So that's the bottom line. Hash maps and sets are your secret weapon for speed and efficiency. They let you trade a little bit of memory to gain a massive, massive amount of time. So I'll leave you with this thought. The next time you're staring down a problem that demands speed, one that needs fast lookups, what tool are you going to reach for?